This is a keyword in C++ which refers to current object. It is actually a pointer which points to the current object. This pointer allows us to work with the object which calls a class member function from within the logic of the same function. An object which is currently calling the function is called as current object for the function's logic. We will learn about this keyword or this pointer in this video. This is the starter code for us to learn about this keyword or this pointer. I have this in this code I have a student class with the data member name, which is to point to a dynamic memory space containing name and ID. It has a default constructor. This is default function. I don't think we need this here. I have not used this function, so I can remove this function. And we have a custom constructor or two argument custom constructor which receives ID and name and copies data into the data variables. We have a set function to set the ID and name into the data variables. We have a display function to display the name and ID, and a destructor. Now in the main function we have statements for creating the objects, and a function for setting data to the object, and the function for invocation of the function for displaying the object's data. Now let us talk about this pointer, the topic of interest, this keyword or this pointer. When we create an object st or st1 or st2, this object is able to call the function. For example, this st is able to call display set function, again display function. From within the logic of this display function, which is over here, if we use this keyword, then in this case, in this invocation, if this keyword is used in this logic of this function, then that actually is a pointer to this object itself, st. So if I have a pointer to st, then what I can do, for example, I have a student pointer and I actually make it point to st. Then what happens, I can use sptr and call the function display, or I can use sptr and call the function set. And we can also use this pointer if this pointer is being used from inside the function, then we are also able to use this access ID and name through this pointer. Therefore, the purpose of this pointer is to be used inside the function. Now, if same this function in this invocation of display function will actually refer to this another object st1. Same this pointer or this keyword when used inside this display function will refer to this st2 object. That means it refers to the current object, the object which is currently active and which is actually calling the function. Therefore, let us go ahead and try to see if inside all these functions you can use the keyword this. For example, in this case I can use keyword this, and I can actually access the name through this pointer. That means either you can use name directly, or you can use this name as a member of this pointer, or you can access this through the pointer using pointer syntax, or you can also access ID using this syntax, or you can access name using this syntax. You can access name using this syntax, or you can access ID. You can access name using this syntax. You can access ID using this syntax, and so on and so forth. You can do the same, use the same syntax to access this this members ID and name from inside all the functions. And also, if you have, for example, if I want to call this display function from the destructor, then I can do like, I can either directly call display function like this, or I can also use this function, this pointer, to actually to refer to or to access display function. So either this is a private function, private members, or the public members. If you are actually trying to refer that current object from within the scope of the class, then we can use this keyword. Right now, if using this one thing you should keep in mind is that if the member is directly accessible without using this pointer, then you should not use, because having this in this case is redundant. If it works, code works, or logic works okay without having this keyword, you should go for that. The logic without using this keyword. Sometimes you may need to have you may need to use this keyword. For example, uh, uh, in this case, no, let me create a new function to just to demonstrate the situation where you may actually to use uh, need to use this pointer. Let me have a function void fo. It receives two data, int val and character ch, and this val is actually gets added to this name, sorry, ID, and this character ch gets appended to this name. So here, if I create another local variable ID, which is of the same name of this ID variable, in that case I cannot after you define this, you cannot use this ID, because from this point when it is defined up until the end of the function, this ID function actually overtakes or shadows the data member. Therefore, in this case, in case you have the variable with the same name inside the function, then you must use this to actually access the data attribute or data member. And if you want to copy, because this is a computed value, if you want to copy this to the data member, then you must use, in this particular case, equals to ID. And when talking about the name, if I want to append this ch into the name, then I would create a local pointer, because I need to increase the length of the dynamic array, the array pointed by this name. Then if I, let's say, if I give the name of this pointer as the same as the name of the data attribute name, in this case new, let me have a dynamic memory allocated chr. I actually want to allocate memory space that is sufficient to hold this content plus one extra character. So length of name plus one character plus one for null character. So you need to allocate this amount of memory space. Suppose this is the length, then let us have a statement to compute this thing here, name. Now at this point you can access name attribute because this pointer has not been defined, but once it is defined then you can access that. Now now you copy name, and now you cannot use at this point the data member. You need to use this pointer to actually access the data member name. Now when you copy, then at the end of this copied string name, I actually want to add this character ch, and the place I want to add this character would be in this place, name equals to ch, and then after that I would put null character plus 1 equals to null character. So this will actually append that character into this local, dynamic array. Now I want to actually make the data attribute, data member, to point to this this dynamic memory. So first I need to clear the memory, delete this name, and this name equals to name. Right. So now we have copied the data into this locally created dynamic memory, and then we delete the existing dynamic memory, and we actually just copy this address to the data member name. Now we have actually copied it. So in this case you can see this we have created a case where we must use this pointer. So here use of this pointer is justified, but in this function use of this pointer would not be justified in this particular logic. So let us see, let us use this function. Here I actually want to, I have this object with 2002 and Sally, and let me call that function that I created foo, and pass, let's say, 5 and space and st2 foo. Let me add 2 and 2 0. After that h st2 0 o. It should actually, I expect the result after this execution, this statement execution should be the ID would be 2 plus 2 2004, and this string would be, it would add space for the first time, and then add h and then o. That means Sally Ho would be the name that would be displayed by this function. Let us see how it goes. I want to actually switch to the terminal and execute this code, compile first. I think I actually this is a typo, so let me go back and make a correction. HTR, it should be what is it? Yeah, strcpy. So let's go back to the terminal and run it again. So now you can see this was actually displayed, 2004, and the Sally Ho was the name. right? So 1001 Jackson, uh, because it is displaying for 2 times because we have that function called from the destructor. So when let me go back to the code and explain, because just take a note of this. 1001 and Jackson displayed 2 times. This Sally who displayed 2 times, and after that this this is the same thing that is displayed over here, and this is the same thing that is displayed over here. So let me go back to the code. Now the reason we that appeared for 2 times is that we have this display function in the destructor. So let me uh, remove this and try to compile one more time. So we have one time Jackson and Salihu, right? So let me go back to the code again here. So it was appended, and 2022 was added to it. So this is the case, and sometimes one application that we will come across when I talk about the operator overloading. Uh, Sometimes if for example in this case I want to actually call this display function in this form. So if I want to call this display function, then I expect this entire thing to be an object, especially st2 object itself. So what I want to do is, once this function is called, then I want that function to return that object, right? So if you are referring to, if you want to return the object from inside the function, then the thing you have to go for is the this pointer, use of this pointer, because this pointer is the thing that actually refers to the current object. So to make this code, this statement work, we need to go back to the function, this function, and we need to actually return the current object. Either you can, let me just return uh, this. If you want to return this pointer, then your return type should be something like this. It should be student pointer. Right now, if return type is student pointer, then you can return this. But if you want to return a student object, then you have to dereference it and return object like this, right? So now let me go for the pointer return. So pointer, then I need to make a little bit small change here, because if this function actually returns pointer, then I would use this syntax to access the member. So this is the syntax that I should be using here. Okay, so let me see. I expect this same thing displayed 2 times by this invocation and this invocation, same data or same line. You know, I expect this thing displayed twice. So so we can see this has been displayed twice. This was the outcome of the previous version, the pointer returned, and invocation of display through the pointer, and this was the result of the invocation of the display function through the object itself. One final note before I complete the discussion on this topic. You should be using this pointer only it is needed. You should not populate your code with this keyword. So that is the, if you want to follow good programming style, so you have to um, avoid using this pointer if it is possible to use it. This is the end of this discussion of this topic. Thank you for watching.